So in section 4.4, we actually looked at situations in which there were three variables. There were two dependent variables, such as f and that we called f and g, or distance, such as distance, that were related to one independent variable, just time. Um, but in this section, we're going to study relations of three variables, but we're not going to be concerned with which ones are dependent and which ones are dependent. So since we don't care which ones are independent and dependent, we're going to write just all the variables on one side of the equation and constant on the other. For example, we could have 2x plus y plus 4z equals 12. So, and a solution to this equation is going to have three answers, which can be called an ordered triple. For example, let's say the solution was 4, 0, 1. This would be a ordered triple for x, y, and z, and we're going to always list them in alphabetical order. So it would be x equals 4, y equals 0, z equals 1, but this is not necessarily the solution to this problem. It's just an example. But yeah, unless otherwise specified, variables and ordered triples or any ordered n there will come in alphabetical order. So equations with three variables can actually be graphed on a three-dimensional Cartesian coordinate system. So in addition to the x and y axis, we're also going to have a z-axis that's perpendicular to the xy plane, passing through the origin. So really, if you can imagine, here's the y-axis, the z-axis is passing perpendicular to this plane. So I know this can kind of be hard to see, but a way you can imagine this is if z and y were the base and height of the cube, x would be the depth of the cube. So, yeah, and these are just the positive x, y, and z axes, but the graphs continue in the negative direction. Like this would be x in the negative direction, the z in the negative direction, and the y in the negative direction. So plotting an equation on the three-dimensional plane to like 2x plus 3y plus 4z equals 12, this can be accomplished by picking values of one variable and seeing what we get for the others. So let's say we set z equal to 0. Then what's going to happen is we're going to end up with, if we set z equal to 0, we'll end up getting 2x plus 3y equals 12. And I'm going to call this equation 1. And then if we set z equal to 1, we're going to get 2x plus 3y plus 4 equals 12. And solving that, we're going to get 2x plus 3y equals 8. And I'm going to call this equation 2. If we set z equal to 2, we're going to get 2x plus 3y plus 8 equals 12. So this is going to get 2x plus 3y equals 4. And we're going to call this equation 3. So when z is a particular value, we get basically different equations on the x and y plane at that particular value of z. So if we draw these values on the plane, or on the 3 coordinate axes, let's first draw that, our 3 variable coordinate system. So we're going to and then this would be the z, and then this axis would be x. And these are all positive axes, remember. So now we have, first when z is equal to 0, we have this ray from the value of x at 6 to the value of y at 4. So we'll draw that first. So we're going to have So there will be a point right there, and then that goes to the value of y at 4, so we'll count 2, 3, 4. And then we have the value of x at 4 to the value of y at a little greater than 2. Whoops. And then we have the value of x at 2 to the value of y at a little greater than 1. So as you can see, we're by drawing these three, we're actually getting a plane in space when we set z equal to 0. So the graph of a linear function with 3 variables is going to be a plane in space. So now once you realize like what the graph looks like, you can draw it more quickly using values given by setting z equal to 0. So similarly we can get planes in the yz trace and xz trace if we set x and y equal to 0. So by drawing these three traces, we can get a reasonable picture of the plane that we're trying to get by the equation. So to draw a reasonable picture of this graph, we're going to want to find values of the x, y, and z intercepts to plot on our axes, as well as the xy trace, the yz trace, and the xz trace, which are found setting one of the variables equal to 0 and getting an equation from that. So let's first find all the intercepts. So the intercepts will be found by setting the two other variables equal to 0. So we're going to first find the x-intercept, which will be found when 2x equals 12, and which means that x would equal 6. So we'll count 1, 2, 3, 4, 5, 6, and here will be the x-intercept. The y-intercept will be found when x and z are set equal to 0, so that will be just 3y equals 12, meaning y equals 4. So we'll count 1, 2, 3, 4, and have the y-intercept right there. The z-intercept then will be found by setting both x and y equal to 0, so we'll have 4z equals 12, and then z equals 3. So we'll count 1, 2, 3. At this point, we need to find the xy trace, the yz trace, and the xz trace. So the xy trace is going to be found by setting z equal to 0. So we're really going to get 2x plus 3y equals 12. So when you graph 2x plus 3y equals 12 on the xy plane, you're actually going to get a line that passes through these 2 points. So our plane is going to just be a connection of those two. Finding so this line would be 2x plus 3y equals 12, and that's the xy trace. Finding the zy trace, we need to set x equal to 0. So to do that, we're going to end up with 3y plus 4z equals 12. So, and it turns out that this trace is graphed on the zy plane. We're going to just get a line that passes through these 2 points. So this would be the equation of the zy trace. Then finding the xz trace, we just need to set y equal to 0. So we'll get 2x plus 4z equals 12. And then this equation turns out is going to be a line that passes through these 2 points. So our plane, our plane that is graphed by 2x plus 3y plus 4z equals 12 turns out to be this section right here. So in order to graph these equations with 3 variables, all you really need to do is find the x, y, and z intercepts and then draw the plane from there.